Hello, I am Remedial from ABM183, and today we are going to be talking about relations and functions. So first things first, what is a relation? So a relation is quite simple. A relation involves two variables, the x variable, which is also called the domain, and the y variable, which is also called the range. So both of these variables involve certain pairs. So under the x variable here, under the domain, we have both 3 and 7, and under the y variable in our example, we have a, b, and c. So we have two sets of variables, and in our example, 3 is paired with b, and 3 is also paired with a, whilst 7 is paired with c. In relation, the domain, also known as the x variables, are paired with the range, which is also known as the y variables. So what is a function? So a function is a relation as well, but unlike this example we have here, what makes this relation a function is each single variable inside of a function only corresponds to exactly one variable. Only one variable in the domain corresponds to one variable in the range. So in this function, we have 1, 7, 8, while here we have E, F, G. So in this function, 1 corresponds to F, 7 corresponds to E, while 8 corresponds to G. So every single variable in the domain only corresponds to exactly one variable in the range. About relations and functions. So now let's learn how to identify a relation from a function. So right now, we have two graphs, and we are going to use the vertical line test to test if it is a relation or a function. So with a function, each domain and each range is only paired with exactly one variable. So now, let's check if the domain, which is x, is paired with only one variable in the range, which is the y variable. So using the vertical line test, we can see how many ranges the domain is paired with. So this graph passes the vertical line test and is a function, whilst this graph, if we try the vertical line test, we can clearly see that the domain meets two y variables. So this relation is not a function, whilst this one is. Talking about how you can use relations and functions in the real world. So first, let's go with relations. So with relations, one common example that we can use is something that many people use to go from one place to another, which is an automotive vehicle, also known as a car. So if, for example, the domain is just 1 gallon of gas and the range is the destination you can go with your car, here we can see with 1 gallon of gas, for example, if you were in Pasay City, you could reach multiple areas. Maybe with 1 gallon of gas, you could reach Paranaque City, you could even reach Makati City, and you could even reach Manila City. So with 1 gallon of gas from Pasay City, you could reach different cities with 1 gallon. So now let's go with functions. So functions is, you can apply them in real life with situations such as fossil fuels in the world per year. So for example, the domain is the year and the range is the fossil fuels. So every year, our entire globe loses fossil fuels. So for example, in 1990, 2000, and 2010, maybe the world had around 3 million fossil fuels within a specific location, and within that location, it would continue decreasing because we consume fossil fuels. So maybe this year, it could be 2,800,000, and maybe by 2010, it would go as low as 2,500,000. So the difference between these two situations, which makes this one a relation, which makes this one a function, is with this relation, the domain has multiple ranges, whilst with this function, per year, each domain only has one specific range. Piecewise functions. So piecewise functions are just like normal functions, but they have multiple parts. So they have multiple parts involving conditions. So this is one part of the function, which is 3x plus 4, and this only applies if x is less than 2. And we have another part, which is 3x minus 7, and another condition, which is x is equal to or greater than 2. So we're gonna have two examples for both of the conditions. So the first condition is, we're gonna have two conditions, which is f equals to negative 2, and we have f is equal to 2 itself. So first, let's start with x being less than 2. So let's start with f to negative 2. So f negative 2, which one should we choose? Should we choose condition 1 or condition 2? So negative 2, which is bigger, 2 or negative 2? Since negative 2 is less than 2, we are going to use this condition. So 3x plus 4. So we're basically going to replace the x with negative 2. So 3 times negative 2 plus 4. So 3 times negative 2 is negative 6. And plus 4 is negative 6 plus 4, which is negative 2. So we found out that f negative 2 equals negative 2 because of the conditions. And the next is f equals 2. So we have to choose which condition we're going to use again, condition 1 or condition 2. So f with 2 is, x is not greater than 2, but x is equal to 2, so we're going to use this one. So we're going to rewrite the function, which is 3x minus 7, but we're going to replace x with 2. So 3 times 2 minus 7. So 3 times 2 equals 6. And then 6 minus 7 equals negative 1. So with this function, with this piecewise function, we found out that f, if it equates to 2, equals to negative 1. And if it equates to negative 2, it equates to negative 2 as well. Let's learn how to evaluate functions. So here is one function, 3x plus 2. So let's give x a value. So x equals 2. So the way you evaluate this function is basically you rewrite the function, but you can replace x with the value given. So the value given in this function is 2. So we're going to be replacing x with 2. So it's 3 times 2 plus 2. So 3 times 2 is 6, and 6 plus 2 is 8. So x equals 8. Operating functions. So operating functions is quite similar to evaluating functions, but it's a little bit different, but essentially the same steps with just an addition. Okay, so we are going to show you how to operate functions with this example. So function A is 2x plus 2, and also function B is 3x plus 2. So if you're given the task to do A plus B 2, you're basically just going to copy the functions. So copy function A, 2x, but instead of x, you're going to write 2 plus 2. So 2 times 2 is 4 plus 2 equals 6. And with B, you're going to do the exact same thing, 3x, but 2 plus 2. So 3 times 2 is 6 plus 2 equals 8. So since it's addition, A plus B, so 6 plus 8 equals 14. So A plus B 2 equals 14. So there are different ways to operate functions. You can do addition like this, but you can also do subtraction, which is A minus B. And you can also do multiplication and division, which is A times B and A over B. So with subtraction, you would basically do 6 minus 8. So 6 minus 8 would be negative 2. 6 times 8 would be 48. And 6 over 8, 6 divided by 8 would be 3 over 8. 3 over 4, I mean. So this is what we are going to learn about composition functions. So composition functions. So we are going to have two functions, which is A and B. So function A will be 3x plus 3, and we will have function B as 3x plus 2. So for example, you are given A of B x. So A of B and then x. So what are you going to do with composition functions is you are going to, if it's A of B x, you are going to replace the x values in the function with B because it's A of B. So you rewrite A, but instead of writing x, you rewrite B since it's A of B. So 3x plus 2 and then plus 3. So first step is you distribute. So 3 times 3x is 9x, and 3 times 2 is 6, because 3 times 2 is 6. So put down plus 3, so you get 9x. 6 plus 3 is 9, so 9x plus 9. So you get A of B x equals, wait, hindi magaling framing.